So let's talk about the variables. Variables are the memory addresses and they can store some value. So why we need to store some value is because we cannot remember that value all the time. So that's why we assign a name to that value. So we can reference that value with that name later on. Rust is this strongly typed language. So that means uh, we need to specify each and everything. Let's take an example. So in Python, I can say a is equals to 4. So a is equals to 3, and if I go and print a, I will get the value 3. So you no need to declare that a is a integer type or any other type. I can still assign this one to some string. So the Python will dynamically take this value at the runtime. That's not the case with the Rust. It is statically strongly typed, and we need to define the data types during declaration. So let's see how we are going to define variable. So we'll be using the let keyword to define the variable, followed by the variable name. So let's say balance and is equals to, let's say, 50. And if I go and press Ctrl S, you can see here this one in the gray box colon I32. So that is being specified by the Rust analyzer. So by default, if you do not specify anything, the Rust will assign I32 value to this integer. So I32 stands for signed integer 32 bits. So we have I32, U32, and U16, I16, U8, I8, and U64, I64. So I stands for signed integer. That includes negative integers as well. So the main difference between the signed and unsigned is unsigned are positive and signed are negative. So the most significant bit, that is leftmost bit, will be set to 1 in the signed integers, and in unsigned they takes the full bits as a value. The MSB does not matter. So 32 means we are representing this number in 32 bits, and 16 means we are representing this number in 16, and 8 means we are representing in 8, and finally 64 bits. So the number is so small it can be fit into 8 bits, but if you assign 32 bits, then remaining the bits will be 0. So let's go and say let a colon. You can also specify the number of bits as well. So let's say U8. So this will take the value from 0 to 255. So we can assign something like 13. And now I am going to print this value. So let's also declare another value. Let b is equals to I16, and this will take up to 65535, I guess. So that's anyway. So we have two variables. Now we are going to print these variables using printer and macro. So this is the format argument. So there is one argument, you can pass another one, and I can say and I can place another placeholder, and I can pass b. Now let's go and run this. Now the output should be 13 and 123. So let's run this, and you can see the output 13 and 123. So this might be very confusing. You can also put the numbers here 0 and 1. So the a gets filled into this 0 position, and this b gets into the 1 position. If we go and run this, we will get the same output. We can also change this to 0 as well, and since we are not using b here, we can delete this one. So now the output will be 13 and 13. So this is how you print the variables. Now in other languages, you can easily change the value using a is equals to 20, but in Rust you will get the error, because by default these are immutable. Immutable means they cannot be changed by default. In other languages, the variables are by default mutable, changeable, but here in Rust you will get the error cannot assign twice to immutable variable a. So to change this into mutable, you need to do is you need to add the mute keyword, and you can see now the error has been gone. Now if I go and print the value of a, I can see the value will be 20. We'll be talking about the mute and ownership and borrowing in the next video. Now you can see the value 20 in the output. There is another concept called shadowing. So without this, let's say you can redefine another variable with the same name. B is equals to, let's say 50, let's say 75. So this is called shadowing. So this means this variable b has shadowed this value b. So the latest one will be 75. So let's go and run this, and 75. So this is called shadowing, and this will be applied to blocks as well. So here you can see the open brace and closed brace. Inside these are valid, and if we gone out of scope, these are invalid. So let's define another scope. Now let c is equals to 15. Now if I go and print this, c is, and I can happily run this one. So let's go and copy this one and paste here. I will get an error. C is, where is this? We need to highlight on this particular red color line. Cannot find value c in this scope because this c is only valid within this open brace and closed brace. If we gone out of this closed brace, the c value will be dropped. So let's remove this one, and we can also access the variables from parent scope into the child scope. So we can treat this as a inner scope or child scope. We can treat this as outer scope or parent scope. So let's go and say we have already see. Let's go and access. Let's delete this, and we can also redefine this one. Let b is equals to, so here b is 123. We can also define b I16 is equals to 200. Now if I go and print this value, I will get 200, and out of, when we gone out of this scope, then this value will be preserved. So let me also print this before entering child scope. B. So let me copy this one in the child scope. Got back into main scope. So whenever we print here, the value will be 123, and when we gone inside the scope, this value will be shadowed this value. So here it will be 200. Whenever the scope has been ended, the old value will be shadowed. So 123. So we will get the output 123, 200 and 123. So let's go and run this. So here you can see 123 before entering scope. In the scope we got 200, and out of the scope we have 123. If we have declared this variable as mutable, then this changes. Then it will act as a regular variable. So here you can see a is mutable. So I can say a is equals to, let's increment this value 13 by 100. Now this will affect directly on this variable itself. If I go and print the a value, it will be incremented by 100, which is 113. So here you can see 113. So if you declare mutable, then scope does not matter as long as you change the value. it will be affected in the main variable, so actual this location. And the next one is we can also print these sizes. If you want to print size of i32, so we can use std create mem, and we have a trait that is size of. So we have seen in this in the previous video, don't worry about this one, we will be discussing in the upcoming videos. So we are just printing the size of i32, so we can copy this one, size of u32, which will be the same, and let me change this to 64. And we also have the floating point values and integers, sorry, booleans as well. So we can say let pi f32, so this is float 32 bit, so we can say 3.141. so this is the floating point value, which will also take the same. And we also have booleans, let's say flag value, you can say colon bool is equals to true. We can also print the size of bool as well. So let's go and run this one. And here we can see these are in the bytes. So i32, u32 4 bytes and 8 bytes, and boolean is 1 byte. And we also have constant variables which cannot be which their values cannot be changed. So let's say pi f32 is equals 3.141. so because the pi value will be constant, it won't be changed. We can also put this mute keyword, you will get an error, but you can change the value with the unsafe block. So we'll be discussing unsafe block in developing malware. So in that block you can actually change these constant variable values. So we'll be seeing that in those malware development videos. So for now this is the constant variable, sorry, constant value, not a variable. So you can also print the maximum and minimum values this data type can hold. So let's say max i32 colon max. So this gives us the maximum value that the i32 data type can store. Similarly i64. So let's go and run this. You can do this with all the data types. So here you can see the big value, this much amount of number we can store in i64. And also one more thing is we should be very careful when using these braces, because even in loops like while loop or for loop, if you are using some let's say let I is equals to 0, then if you are using this variable in a loop, then this is going to be wrong value, because we will be say, let's say my loop while I something value. So let's say this is the loop, and if you are going to update here, then this may raise a problem, because the outer value will be 0 and this will always be true. So that's why there is another loop called loop. So we will be discussing this loop variables in the loops video, so then it makes more sense. So this is all about the video on variables, scope and shadowing.